every day.
Yes.
Wow, that's nice. Okay, look at the question that we have now. So I want us to quickly push this question 7. Uh, First question, it says that determine uh, first principle, the derivative from the first principle if f at x it's equals to x squared plus 4x plus 1. So I'm going to rewrite my equation this side. You can see my screen, right?
Yes, sir.
Okay, so this will be, they want us to find f at x. It's okay, f at x is equals to x squared with minus 4x plus 1. Right. So when they say f prime from the first principle, so I'm not sure, but if you still remember the first principle, it goes like f at prime is equals to the limit as h approaches 0, then
Yes.
we say that we need to find f at x plus h, okay,
Yes,
minus
sir.
f at x. Then we're going to take everything there, divide everything by what? Divide everything by h.
H.
Right. So now you know what I'm going to do when I have this type of question. First thing first, I need to find f at x plus h. So meaning that on the equation where there's x, I'm going to substitute that x plus h and see what I get. Where there's x, I put x plus h plus 1. Right. So if I expanded the bracket here, this is x plus h into x plus h minus 4 into x plus h. Okay, therefore, let's multiply out the bracket. But already, since we work with x plus h squared most of the time, already we know that when we multiply the bracket, this is x squared plus 2xh plus h squared. Then we minus 4x, then minus 4h, then we have plus 1. Are you with me on that?
Yes, sir.
Can I take this and substitute it on that limb?
Yes.
Okay, let's quickly do that. We know that the limit sh approaches 0. My f at x plus h, I'm going to sub in this, which is the x squared plus the 2xh plus h squared. And then I'm going to rewrite that part there. Let's subtract, okay, f at x. So please make sure that when you subtract f at x, you put it inside the bracket. This is one of the things most learners forget to do, so that they can multiply out the bracket with that negative, okay? Then this is
Okay,
over
sir.
h. You still with me?
Yes, sir.
Okay. So now, what do I get when I multiply out the brackets?
Um, Let me just multiply it. The bracket is
Yes,
going to be negative x squared plus 4x minus 1
plus 4x minus
plus 4x. Yes.
that over h. Can you please
Yes.
give me as I continue with this one? So now I'm going to look at the like terms. I'm going to cancel out those like terms. Now I'm going to look at
Mm-hmm.
the like terms and then we cancel those guys. So the x squared cancels with minus x squared. And then
Yes.
the 4x cancel with minus 4x. And then the
Yes.
minus 1 cancel with the plus 1. So a quick tip is that whatever that you have on f at x, it will be like everything will be cancelled inside that f at x. You understand?
Okay, sir.
Then after cancelling out of the terms, you need to rewrite your equation carefully. Make sure that you don't miss any term there. So this will be 2xh, then we have plus h squared, then we have minus 4h, and everything is divided by h. So when I look at the top part, I can take out h as the common factor, because now we cannot do a direct substitution. If we do a direct substitution, everything will be a mess. We're going to get a 0 at the denominator of 0, which is undefined.
Yes,
so from this part, I'm just going to take h out as a common factor. I'm left with 2x plus h minus 4. And when you divide this by h, the h cancels. I'm left with the limit as h approaches 0 of that 2x plus h minus 4.
minus 4.
Let's do the
Yes.
substitution. Now, when you substitute,
Now
you
make
drop the
H4
limit.
0.
Okay?
Sorry, so you can speak.
You say?
No, sir can speak. Sorry.
Oh, okay. So this is 2x. Where there's h, we substitute 0. Then the final
Yes.
answer is just 2x minus 4. Okay?
Yes, sir.
Right. Look at this. Né? Another exam tip that I can give you is that when you apply the limit, the first thing you can just factorize. I'm sorry. You can differentiate this using the rules. So if you use the rules, this is 2x minus 4. So those tells you that after using the principle, your answer should be 2x minus 4. So if you work out this thing and you find 2x minus 4, then that's when you can start smiling when you are in an exam. Né?
Okay, sir. Thank you.
Okay, let's look at the next question. If f prime, they want us to find f prime. If we have, so this one we have to apply the rules, né? On 7.2, and we need to apply the rules. So we have f at x, which is equals to minus 3x to the power 4 plus 5x squared. Therefore, the f prime at x. So I think it's best if we just rewrite this equation this side, and then we'll work on it. So this is 7. Okay, so this is 7.2.1. Okay, so we are looking for f at x, which is equals to minus 3x to the power 4, then plus 5x squared. The most important rule of differentiating is that if I have f at x to be x to the n, the derivative of this, the f prime of x, will be the x comes down, no, the n comes down to multiply the coefficient of that x. So this will be equals to n times x to the power n, then we subtract 1, right? So this will be, we need to find the derivative here. We're going to bring the 4 down, which is minus 3. We multiply that by 4. And then this will be x to the power 4. We subtract 1. Then plus 5, we bring the 2 down, multiply that 2 by 5. X to the power 2, we subtract 1. Therefore, what do we get there? What is your f at x? If I work out this, my f prime will be minus 12 x to the power 3 plus 10 x. That's the derivative, right?
Yes, sir.
This was an easy one, but when we look at the next one, this one, we need to first remove the sides. We need to remove that square root. We need to remove the fraction before you do anything. Né? So they say dy over dx, meaning that differentiate y in terms of x. So this will be 2.3. They want us to differentiate y in terms of x. So we are given y to be the root x minus 2 over x. We need to rewrite this equation. I'm not sure if you still remember the laws of exponent. If I have x to the n, the root m. So this can be written as x. The exponent inside the square root comes on top, divide by the one that is outside. So this is to the power 1 and this is 2 there. We can write this as x to the power, the 1 comes on top, then the 2 as your denominator. So this is the same as minus 2. Remember, 1 over x is just x to the power minus 1. We can write that as a negative exponent, okay?
Yes.
Now you can differentiate. So we can find the dy over dx. So when we differentiate, the 1 over 2 comes on in front, then x to the power that 1 over 2 is subtract 1, minus 2, which will be multiplied by minus 1, and then we're gonna say x to the power minus 1 minus 1. Therefore, when we work this out, what is dy over dx? This is just 1 over 2. X to the power 1 over 2 minus 1 over 2 is just minus 1 over 2, right?
Yes.
Then we're going to add 2, x to the power negative 2. Okay, so you can leave your answer like this, or you can just put your answer in a positive, or if you want to bring back the fraction, it's up to you. So you can simplify this further and say this is the same as 1 over 2. We know that this is 1 over 2 and is divided by x to the power 1 over 2. And then plus this is 2, which is divided by x squared. You can also put in the fraction and say this is 1 over 2 over the root x. Then, yeah, and so on. 2 over x squared. You understand?
Okay, sir.
So it's up to you what you want to do about that. Okay, let's look at what we have on the next question. What are we required to do? They say that determine the equation of the tangent. They want us to find the equation of the tangent to a curve of h at x. Okay, so this is our main graph. And then the tangent should touch that graph at one point at x is equals to minus 2. You understand?
Yes, sir.
So this tells us that if we can find h at minus 2, we can find the corresponding y value. Okay, so when you have the corresponding y value, we're going to know where it touches the graph. You understand? At which point, because already we have the x, and then we can find h at minus 2 to know where does this touch the graph, the point of contact. Then after finding the point of contact, I'll explain why we need the point of contact, okay? So first thing first, I need you to use a calculator. Punch that on the calculator. Tell me what you get. What is h at minus 2? On the calculator, where there's x, you put minus 2. What do you get? So because this is h at minus 2, it's equals to minus into minus 2 to the power of 3, then plus 2. I'm listening.
What is h?
What is h?
Yes, where is it on the calculator? We didn't do it like this.
Please come again. What are you saying?
I don't know where h is on the calculator.
No, why do you want h on the calculator?
Can't you say put h?
Oh, no, I'm saying on h, where there's x, you put minus 2.
Oh,
Sorry, ne?
I was lost now. Like, where is h?
No, I'm sorry. On this will be h at minus 2. So meaning that where there's x, we put minus 2. Sorry, ne?
Okay, so
therefore, what is the corresponding y value? What do you get?
It's -1.
Okay, so if this is -1, therefore the point of contact, the x is minus 2, the y is minus 1. I'll explain why. Because remember, the standard form of a tangent line, it's a straight line, so it should be in the form of y is equal to mx plus c. We're going to use that point to find c. But now let's first find the gradient. We know that to find the gradient of a tangent at a point, we find the derivative and then we substitute that x value to find the gradient. Do you understand? So we need to find the derivative of that h. So I'm going to work on the derivative. I'm going to look at the derivative. Then after having my derivative, I'm going to substitute where there's x, I'm going to put minus 2. So the derivative h prime at x, this will be equal to negative 3x squared, then plus 2. So that is the derivative. Né? So
Yes,
now
sir.
on the derivative, to find the gradient where there's x, we need to put in minus 2 plus 2. Therefore, the answer that you get is going to be your gradient. It will be the value of f. What is that? So this is 6 plus 2. Né? Eh? Is it? Oh, this is 2 squared.
Yes, sir.
It's minus 3, which is 4, and then 4 times 3, that's minus 12, plus 2, that's negative 10. That is the gradient.
Yes.
Right?
Okay.
So you see from this equation, I'm going to substitute in my gradient, y is equal to minus 10x plus c. Then use this point. So I think you understand why we had to calculate the point of contact. So now we need to use that point of contact to find the corresponding, the value of c. So where there's y, I put minus 1, and this is equal to minus 10. Where there's x, I put minus 2 plus c. Then you just have to take it from there and solve this guy. So this will give us minus 20 plus c, and then this is minus 1. Oh, this will be positive since it's a negative and a negative. Therefore, the 20 will go to the other side to be negative. So negative 21 is equal to c. So what is the equation of the tangent at that point? Therefore, the equation is y is equal to minus 10x minus 21. That's the equation of the tangent. Okay?
Yeah, this one is less complicated.
I'm listening.
I'm saying Sir's equation is less complicated than the one I was doing.
Okay, this, which one? You guys, when you calculate, you use this one, y minus y1, it's equal to m into x minus x1.
Yes.
I think even this one, man, it's good. It's just that you have to make y subject of the formula, multiply out the bracket by the gradient, which is where you can just make a lot of mistakes, né?
Yes, I like this one. It's more straightforward.
Okay, I understand you, né?
Okay, sir.
7.4. Look at 7.4. They say that they want you to find the graph G prime has a minimum turning point. Okay, at 1 and minus 4. Oh, determine the values of x. Okay, so this 7.4 is no longer part of 7.4 is on its own. Eh? This is a new question again.
Okay, sir.
Okay, do you want me to give you a chance to try how to answer this 7.4?
No.
Okay,
no.
Look at this. Now, they say that the graph y is equal to g prime at x. And then when you see the weight minimum, just know that we're talking about the first derivative. Né?
Okay.
Okay, we are referring at the first derivative. But now, it has the minimum. So they are talking about the turning point at that point. So it has the minimum turning point. So I'm not sure how can I show you this? If I have a graph like this and they say it has a minimum, so this is my minimum turning point, this is my minimum, and this is my max. You understand?
Okay.
And then they say determine the values of for which G is concave up. Ne? Concave up. So if we determine the concave up, we're going to find the second derivative, and then it must be greater than 0. You understand?
Yes.
Okay.
Because
So
it's
now,
concave up.
yeah. So now, when this graph has the minimum turning point, it tells me that I'm just gonna quickly give you an example. Né? So you see this point, this x value. Okay,
Yes.
so this x value, it becomes what we call, since is the second derivative is it becomes what we call the point of inflection. You understand?
Okay.
The point of inflection is where the graph changes the concavity.
Okay.
So when they say it has the minimum turning point at that point, and they say for which values of x is the graph concave up, you need to take the x value, which is 1. So x must be greater than that 1. That's the answer. And when they say the graph is concave down, it will be x must be less than that 1. So this one is for concave down, and this one is for concave up. So you just have to understand that the second derivative, it should be greater than 0. And then for down, the second derivative, it should be less than 0.
Okay, sir.
Are you happy with that?
Yes.